Tuesday, everyone. If I say hep hep, you say hooray. Okay, children? Hep hep, hooray! Hep hep, hooray! Wow, very energetic. So today, we will conducting an experiment about the denaturation of proteins. So let me ask you first, what is protein denaturation? Anyone? Protein denaturation is the partial or complete disorganization of a protein's characteristic three-dimensional shape as a result of disruption of its secondary, tertiary, and quaternary structural interactions. If you want to know the result, interpretation, and conclusion about the experiment, please do keep watching. So here are the results and observations. In the control, as observed in the experiment, as its purpose remained the same, this will serve as a basis for the physical changes in relation to different agents used. While in the tap water, as noticed, it has a small white gel-like object, and after adding the egg white to tap water, slight denaturation of protein was observed. Although egg white was not denatured totally, some of the proteins from egg white was denatured. In the detergent, it was observed that there was minimal denaturing effect on the egg white. And also, when I hold it, it was very sticky and it's like a soft gelatin. However, in the vinegar acid, it was observed that the vinegar denatured protein like heat and UV rays. And also, it was considered to be the second most denaturing effect to the egg white. In 45% alcohol through denaturation was observed, it is not much as 70% alcohol. As the higher concentration of alcohol, the higher also the chance of protein to be denatured and vice versa. In this situation, since 45% alcohol was lower concentration, as 70% alcohol denaturation of protein will also be lower. As the 70% alcohol also denatured like the hot water, but the denaturation of protein was more observed in the alcohol. However, comparing the tap water from hot water, we can observe that hot water denatured the egg white more than the tap water. While here, still protein denaturation is observed under its exposure to sunlight. The experiment shows different ways on how a protein can be denatured to its natural state, using different denaturing agents. The denaturation time was 30 minutes for each denaturing agent. Denaturation of protein includes modifying its molecular state, causing it to break many of the weak bonds in the molecule. In this case, egg whites were used which contains proteins like albumins, globulins, and mucoproteins. Although the main protein found in the egg is albumin, they are clear and almost 90% water and the remaining 10% are proteins. The control egg showed us that when left at room temperature, the egg whites stay clear, meaning the proteins maintain their original shape. These proteins were not denatured. There was minimal denaturation of egg white found in tap water, which suggests it has a small denaturing effect on some of the egg white. Although it acts in the same way, by breaking bonds, its effect is not nearly as strong as alcohol or hot water. Detergent also showed minimal denaturing effect on egg white, lesser than that of the tap water. Vinegar was also observed is the second most denatured base of all the solvents. Similar to tap water, it breaks down bonds but to a more extent because of its acidic property. Both alcohols also provide strong denaturing effects, but in different extents depending on the concentration of the alcohol. The higher the concentration, the more it gets denatured. As with the experiment, the denaturing agent with the most is the 70% alcohol. Alcohol molecules bond directly to some of the parts of the protein, disrupting the normal way the protein would bond to itself. So alcohol is called a bond disruptor. The proteins again unfolded, taking up more space and hardening in place next to one another. With hot water, denaturation was similar to alcohol, but also with less extent. When cooking an egg, the ovalbumin starts to denature, meaning it loses its shape and begins to form a white solid through coagulation. Lastly, protein denaturation is observed under its exposure to sunlight. As sunlight contains UV rays or radiation, it supplies kinetic energy to protein molecules, causing their atoms to vibrate more rapidly and disrupting relatively weak hydrogen bonding and dispersion forces, resulting in precipitation of albumin or the protein in egg. So here is our conclusion. With slight differences in the extent to which egg whites are denatured, the experiment and applications of the different solvents and denaturing agents showed in visible observation how egg whites are broken down into smaller, more natural substance of protein. Although some measurements may not be accurately measured, theoretical and factual observations were seen and thus supports the result of the experiment.